kind of welcome Jordi to the stage. Jordi's from Hermez Network, who's also one of the sponsors of the zkSessions event. So take it away, Jordi.
Well, yes, hello. I'm the technical lead of Hermez Network. We are very close to the launch. Actually, we wanted to launch during this week, but there was well, it's not even an issue, but there was an adjustment in the last week in the Poseidon hash. So we decided to adapt, to fix that and to adapt to the reference implementation. So we will have to rerun the trusted setup again, but I hope that probably next week we will be able to launch. We have everything set, and testnet is already there, so we're very excited to the launch. But in this presentation, I wanted to talk to one of the properties of Hermez, which it's about massive migrations. Okay. What's massive migrations? Well, if we see an ecosystem of rollups, so we can have like a lot of rollups. So rollups at the end, it can be understood as if you want a smart contract or as an application that's running some specific transactions, but with a scalability, with a lot of transactions per second. So each rollup may be running. Here you can think, of course, there are payment rollups, but can be also auction rollups. It can be lending rollups. It can be voting rollups. It can be identity rollups. It can be any kind of, I would say, application can run a rollup. And I would say that if applications wants to go mainstream, so they want like thousands and thousands of transactions to run, they will have to migrate at some point to some sort of rollup or any other scalability, but probably rollup is a more feasible for doing now. So once we have these rollups running, how do they communicate? How do I transfer value from one rollup to the other? Okay, so this is about massive migrations. In order to transfer these, from one rollup to another rollup, what techniques do we have? Well, we have I would say the trivial one. The trivial one is you just do a withdraw and then you do a deposit in the other rollup. This is quite well. You just do a couple of L1 transactions, but this is this could be very, very, very expensive. It's doable, but if the gas price of the network increases, this would be very, very expensive. This decentralization is okay, but you need to do this transaction. Another option is do a kind of maybe it's like an exchange. You have a centralized exchange, or you just deposit. You just transfer in the same rollup. You just transfer coins from in rollup 1, and then this centralized exchange just return the funds in the rollup 2, and then it's this exchange who's managing the transfer, the aggregate transfer. But this is not decentralized. It's a centralized exchange. Could be cheap because at the end it's a couple of L2 transactions, one in each rollup, but has this decentralization problem. So in the middle, what we have is these massive migrations. So massive migrations, at the end, what we are doing is when there are many users, in a volume rollup that want to transfer funds in another rollup, instead of each user doing a single layer 1 transaction, 2 transactions in each rollup or for each user, we can aggregate them. And then with a single L1 transaction, we can transfer all these users. In the case of the example, it's 4 users. They can just transfer simultaneously from one rollup to the other rollup, just expanding one simple transaction. These 4 users can be even thousands of users. So in a continuous system where there is a lot of transactions moving back and forth, then this scales because you can do a lot of transfers in the same batch. So I want to explain here a little bit. I'm going to be here. It's a short session, but I'm going to be here put a little bit how this would work. Okay. So the idea is that the destination rollup, how this would work in Hermez. So the idea is that this destination rollup actually holds an account in the layer 1 rollup. Here we have 2 rollups. In the left side we have the source rollup. So these users wants to transfer some assets to the this second rollup is in the right side. So the destination rollup has an account in the source rollup. The people in the first rollup, in the source rollup, they just transfer to this account, okay? And this is transferred to here. This is a smart contract, so this is automatic. It's not a centralized actor here. It's just a smart contract can create a layer 2 rollup in the other rollup. Okay, so here I want to show you some code of how this would more or less work. Okay, so we have a smart contract. This in this case would be this destination rollup. So the destination rollup needs to create an account in the source rollup. How he does that? In the case of Hermez, is just do a normal deposit. In this case, it's a 0 deposit, but just do a deposit. So they create a deposit. In the case of Hermez, when you do a layer 1 transaction, the operator is required to do that in some block in the future, but you know that these transactions for sure will happen. Okay, so here we have the second part of the code is how we identify how the smart contract knows which is the account that they just created. The rollup just create the account, and here we can use. Here, interesting is in the case of Hermez, we can use the withdraw verifier just to prove in the layer 1 level that a specific account is created and has a specific index. So here in the last line, we save what's the index of the rollup of the account inside the rollup. Okay, so once the destination rollup has an account in the first rollup, okay, so they can just transfer funds, okay, and we need to do the transfer. So in order to do the transfer, the first thing we need to do an exit. Okay, so how we move the funds from one side to the other. So here is 3 steps. They can be packeted with the same transaction, but there are 3 steps. The first is doing the exit. A normal layer 2 would do just a normal layer 2 transaction. But in this case, it's a smart contract. A smart contract do not have a private key inside the rollup. They just another account. So what he does is he do what we call it a forced transfer. So if he does a layer 1 transaction, telling to the rollup that he wants to withdraw all the funds. Okay, so this is what we see in this code. We just do an L1 transaction. Here, the trick is the destination is 1. 1 is a special number. That means that you are just exiting. Okay, so once it's exit, then we need to do the withdrawal. This is what actually moves the funds, so the tokens, from one smart contract to the other smart contract. Okay, so here we have the normal withdrawal. In the case of Hermez, we have 2 kind of withdrawals. One that's done with the circuit, the other is done with just Merkle proofs. Here we are just using the circuit one, and yeah, so this just transfers the funds to the rollup. Okay, and finally, but okay, these funds, how we send it back again? How we send to each individual pieces? Well, here the cool thing is that we can. So the destination rollup can have like a special processing circuit that actually does this distribution. This circuit just takes all the layer 1 transactions. If you see so here it takes all, you see here in red, if you see it takes all the transactions that happen in the same batch, okay, and they need to process them. So it takes this is what we call here. So we can, in the case of Hermez, we can we call it here the L1, L2 transactions hash map. So this is a hash of all the transactions that happen in that batch, okay? And process all these transactions to update the state. So we go from the current state, we assign a new state that's actually where it's processed, these transactions that are, so we send this, we add the balance of the destination address according to the Ethereum, according to the same, so that they have the Ethereum address. So, and this process is just processing. So this import process is just like processing a normal rollup, batch. Okay. So here we have all the proof. Of course, all these trees can be packed in the same transaction, and with a single layer 1 transaction, maybe we can move 1,000 transfers from one rollup to, or from one rollup to another rollup or another L2 solution. Okay, so that's very much what I wanted to explain. I'm going to be also in Gather, so if anybody wants to talk about that, I'm glad to do it. And yeah, just here is if anybody wants to test Hermez right now, it's already in the testnet, so you can test it here with wallet.testnet.hermez.io. I hope that during the next week or next days, you can also use that in mainnet. I'm very excited to have this in production and to have the community to use the cryptocurrencies and to scale Ethereum in general. So that's very much what I wanted to talk about, and I don't know if I'm in time or
you're good.
I just lose the sense of time.
There's about 6 minutes before the next talk. So there was a little bit of conversation about the destination rollup and the source rollup. Oh, am I muted still? Can you hear me?
No, yeah, I can hear you.
Oh, somebody just said that I'm muted. Oh, I don't think I am. Okay. I'm sorry, Marcel, for some reason you can't hear me, but hopefully other people can. Okay, so yeah, maybe just, I don't know if we want to go back to that slide, the destination rollup accounts, destination rollup, source rollup. That was sort of there was some question here, yeah.
Yeah, just go ahead.
And I think that, well, the question was just clarification that it's the destination rollup account, not just the destination rollup. And I think that's what we wanted. So that looks really good. Yeah. I don't know if there's anything else to that, actually. I think there was another question from Kev, though, and that's, is this using Groth 16?
Yes, so Hermez is using Groth 16 right now, but the idea is that this migration mechanism can be used to migrate from so from Groth 16, for example, to Plonk, or for example, from Groth 16 of one core to Groth 16 of BLS 381 when it's implemented in Ethereum. So it's like this mechanism can be used for connecting different schemas. Also in Hermez, we provide this, so anybody that wants to integrate with Hermez, we provide this information of which transactions. So we hash all the transactions that happens in a batch. So we can use this hash as a mechanism to import, to get used to import in another rollup. They will just have to decode this and use this information in order to give back the tokens to the specific layer 2 transactions of the destination rollup.
Cool. Feel free to add any other questions in here if anyone has, but I have another question, which is a little bit about, like, you say it's about to go live. You mentioned there's a test net, but like, what kind of time frame should people have in mind? And like, do you want people to actually start engaging now with the testnet, or do you want them to wait? What's your idea?
Testnet, if anybody wants to testnet, and if anybody have feedback or they see bugs, also we are running a bug bounty, not for the UI, but mainly for the smart contracts, the circuits. So if anybody just want to check out the circuits, of course they can. Bug bounty is open and will be open. So it's a good time, especially for devs and early adopters, to start checking it. But in few days, just I hope that during next week. But it's like it's a matter of how the trusted setup ceremony works. But probably during the next week, we will go mainnet. We have everything set. We have everything ready, and just a matter of just finishing this trusted setup and deploying smart contracts and start working with it and start playing with it in the main. Yeah.
I feel like people are excited. I'm curious to see it. Do you have any, like, as you launch, do you have any sort of UI or like test cases already set up? Like, will it be possible for a kind of an end user to already do something?
Yeah, and users, if they connect to wallet.testnet.hermes.io, they will see a full wallet. They can they can deposit it. Right now it's running in Rinkeby in this testnet, but they can do deposits. We also set up a Uniswap, Rinkeby Uniswap, so they can play with other tokens in there. So they can buy and sell in Uniswap, and they can just transfer in and play around with Hermez. They can do deposit, they can do transfers, they can do withdrawals, they can do everything. And we also have a batch explorer. It's explorer.testnet.hermes.io. You can see the blocks running in there. Yeah, of course, it's a work in progress. It will continue after the launch, just improving the UI and improving a lot of functionalities. So have a lot of ideas to do on there. So, but it's like, but right now the goal is just to launch in mainnet and just be the service available for everybody.
Sounds good. There is one last question before we move on. It's actually from Alex, who's going to be speaking after. But Alex asked, are you using non-algebraic hashes for checking batches?
We are using we are using for the hashes, we are using SHA 256. Yes.
Okay. Cool. Well, thank you so much, Jordi. Thanks for the talk, and thanks again for sponsoring the event.
You are welcome. It's a pleasure always to sponsor your events. They are great.
We will see you possibly around the Park Bench panel if you want to jump on and have some ideas, and also after at gather.town.
Perfect.
Cool.